Hi there, I'm Arthur, and I'm here to talk about how you can deploy DNSFilter. Now, when you're looking to deploy DNSFilter, there's 3 different ways that you can go about it. While each of the methods have their own pros and cons, as well as their most common uses, there is no single right way, as it's really going to depend on your environment, your needs, and how much work you want to do. You can even mix and match all the methods within the same environment if you're feeling saucy. The first, and some would say easiest deployment method, is what we call a site or network level deployment. This is a great fit for an environment like a static office building, or even a home with technology that doesn't leave, where there's perhaps a number of fixed devices like workstations, servers, or even IoT stuff like your internet-connected garbage disposal, and where protection is your main focus rather than content filtering. All you need to do is configure a site within your DNSFilter tenant that encompasses that location, and then you need to tell us what IP addresses the traffic will be coming from for that site. In most cases, this is going to be a single IP, but obviously in some setups, you may have more than one. And then once you've done that, you just need to update the DNS forwarders on your edge device of your network, like your router, your cable modem, or your pigeon coop, to be pointing at the DNSFilter Anycast IPs of 103.247.36.36 and 103.247.37.37. And just like that, you're done. Everything that uses that particular network will now have its DNS queries routed through DNSFilter and have the policy that you choose applied to that traffic, ensuring that you're protected. And because you are using the DNS forwarders on your edge device to route traffic to us, no other work is required if you bring new devices into your home. The minute you plug them in, they're just going to work. Obviously, the number one pro to this method is the simplicity. It took us 30 seconds to get it deployed, and it also allows you to cover a large number of devices simultaneously and requires absolutely minimal ongoing maintenance. The number one con to this method is the lack of granularity around reporting. As an example, say that garbage disposal calls out to a host that we block for whatever reason. Could be content related, could be threat related, who knows. Because we're treating all the traffic from this network as a single source of traffic, we have no way of knowing which device on that network sent any given request. Could be the disposal, could be your computer, could be your tablet, we just don't know. It will require thorough investigation to determine the true source of the malicious query. Additionally, in most scenarios, a network or site level deployment will only allow for a single policy to be applied to the traffic. Now, of course, there are exceptions with some NAT tomfoolery, but that's a topic for another video. Ah, yes, easy you say. I love easy, but what if I need more detailed information on which user or device is making the requests that are being blocked? Or what if that person leaves the office with their device? Then what? Well, it's actually convenient that you ask that because we do also have a deployment method that will cover that perfectly, and that's our roaming client. Our roaming client is an installable application available for Windows, macOS, Linux, iOS, Android, and Chromebooks, which will act as a local DNS forwarder on the machine, but as the machine is sending out these DNS requests, they'll be tagged with additional information surrounding the device making the request, as well as the active user on that device, where we're able to gather that information. So imagine from our first example, all the workstations in the office are actually laptops, and these laptops go home with your users every night, but you still want to ensure that they're protected and or content filtered. That's where the DNSFilter roaming client comes in. Because we're handling the forwarding from the device itself, we don't require the IPs of where the user will be on the internet to do our job. And that's a good thing because there's currently almost 40,000 Starbucks in the world. And if you had to add every single Starbucks IP to your dashboard just so your employees could work from a coffee shop, it would take forever. Deploying the roaming client manually is very simple. We've got installers for all the platforms, but you can also utilize an MDM tool to accomplish this. Now, because there's so many MDM tools, it's really impossible for me to illustrate in this video exactly how to do it, but there will be a bunch of great documentation linked in the video description to walk you through how to accomplish remote installation with most of the main MDM solutions out there, as well as providing some generic scripting to use with those that we don't have comprehensive documentation on. Now, as you've guessed, the number one pro of the roaming client-based installation is that you now get granular information around which person and what device is making any given DNS request that is happening on your network. And that's followed very closely by number 2, that they're protected effectively no matter where they are because the agent is going to follow them around on their device. Now, the downside to using the agent is, like any software, it needs to be installed. Now, as I mentioned, this can be done via MDM solutions and will not likely be a huge lift for you, but there's still going to be situations where it's more work than you feel like doing, or definitely more work than it would have been to do just a simple network installation. Obviously, options 1 and 2 are the most common deployment methods that we see our customers leaning on, but as I mentioned at the start, there's actually a third deployment method available, which actually functions somewhere between a network level deployment and a roaming client deployment. That method is called the DNSFilter Relay. The Relay is a lightweight DNS forwarding application with binaries available for Windows, macOS, and Linux, as well as virtual machine images for a number of different platforms, even some Docker containers. We might even have an old Commodore 64 floppy disk kicking around, but I can't guarantee it, so you should probably stick with Docker. You can think of the Relay almost like a slightly more bare bones version of the roaming client, but it works with multiple devices rather than just one single device. So if we go back to our office building from the network deployment example, turn all those laptops back into desktops, and then imagine that across these machines we have a few different groups of staff, or maybe there's a bunch of those garbage disposals in the building. You never really know. We can't install an agent on them, but we still like a little more information about what devices are making the requests that we're seeing. This means we now have a great use case for the relay. If we deploy a relay that is accessible on the internal network of all these devices, and then we point these devices at the relay's local IP for DNS resolution, it will automatically forward the traffic to DNSFilter just like the roaming client, and it will apply the specified policy, which can be set at the relay level, just like a network level or roaming client deployment, but it will also gather the local IP address of the device making the request. This means that you'll be able to see that the device with the local IP of 192.168.1.53 looked up, this site is malware.com. Of course, this doesn't specifically tell you the user on the device that made the request, but at least now you have the information to walk it back to a specific device or local IP, instead of just knowing that it came from the general network and not having a place to start. Now you understand why I suggested that the relay functions in a space between both solutions, the roaming client and the network level deployment. But it actually also has a second tool in its belt that a lot of people find useful, and that's the ability to specify local IP ranges in your dashboard and apply different policies based on which IP range the traffic is coming from. So if we go back to that office building with the machines, say 2 of the machines here have to have policy A. It's the accounting department. They're not allowed to have any funds, so they're pretty locked down. 2 of the machines have to have policy B. This is the marketing department, and they're allowed to look at Facebook at work, unlike the rest of us. And then there's a couple machines that need to run policy C, because this is for the C-suite, and they can do whatever they want because they sign the checks and you want to keep your job. We can simply go into the relay configuration side of our dashboard, specify the IP ranges for each of the groups, and assign a policy to each of those ranges. Now, when the relay sees traffic coming in from the specific internal IP, it will apply a specific policy to that traffic. So now you get some policy granularity as well as device details for these machines without having to install 6 different agents. Now, as I mentioned at the start of the video, there's absolutely nothing stopping you from using 2 or more of these 3 methods within your setup. Once again, going back to our office building as an example, let's say 2 of these 6 workstations are now laptops, and we're going to throw in a guest network as well that any random body can use. So you might look at doing a network level deployment for the guest Wi-Fi so that any outside users on your network are still actively protected at the DNS level. Then you might also do a relay deployment to cover the individual workstations, these 4, and maybe in 2 groups, maybe in 4 groups. And then you can just deploy the roaming clients on the remaining laptops so that they maintain protection regardless of whether or not they're in or out of the office. One of the questions I get asked most often is what happens when my laptop or mobile device with the roaming client is on the same network that is perhaps forwarding traffic to DNSFilter directly at the network level or through a relay or some other method? And the short answer is that the roaming client is going to take priority, and that's what the information, the DNS queries will be tagged with, the user details and the roaming client details from that machine. If the user were to somehow stop the service or quit the application, then the traffic would default to going out over however it's routed on that network and would be tagged or not accordingly. Now, I know I've said a lot, but I hope this helps to clarify what your deployment options are when you're working with DNSFilter, and I look forward to seeing you in the next video.